Hello everyone, my name is Nazatul and my partner Elaine Chan. We are from Group 9. Our project title is regarding the coal power plant. There is one thing that could dramatically worsen climate change: coal. Coal is one of the three main fossil fuels along with natural gas and petroleum. Coal is cheap and abundant in nature. It is classified as a non-renewable energy source and has divided into four categories: anthracite, bituminous, subbituminous, and lignite. Anthracite coal has the highest carbon content, the fewest impurities, and also the highest energy density. The world relies heavily on coal. Around 30,000 of coal-fired power plants are generating 38% of global electric power in 2018. The world doubled its coal-fired power capacity over the last 2 decades as the demand for energy increases. Worst comes to worst, over 1,000 new coal plants are now being constructed. Many Asian countries, particularly China, India, and Indonesia, are expanding the use of coal in power generation. As the coal power plant rises, it will definitely give impacts to the environment. When a coal is burned, it releases a number of airborne toxins and dangerous pollutants. They include mercury, lead, sulfur dioxide, nitrogen oxides, particulates, and various other heavy metals. In this project, we will be focusing on the particulate emission. Particulate matter, also known as particle pollution, includes the tiny particles of fly ash and dust that are expelled from coal-burning power plants. Particulate pollution is a mixture of soot, smoke, and tiny particles that originate primarily from coal power plants. Two size classes are recognized in regulatory schemes: PM10 and also PM2.5. Sometimes they are all regarded as a total suspended particles (TSP). Fine particles are either emitted directly from coal power plants or are formed in the atmosphere through complex oxidation reactions. Particulates are of great concern because they are so tiny that they can be easily inhaled. Coal burning can cause asthma, heart disease, cancer, and premature deaths. In 2013, the World Health Organization said both air pollution and particulate matter are classified as Group 1 human carcinogens, and the risk was similar to that of inhaling secondhand tobacco smoke. In the industry, pulverized coal combustion (PCC) is the most common technology to produce energy from coal. In this process, coal is pulverized by coal mills in order to be ground to fineness. An airstream as oxidant is injected into the coal mills to form an A-coal mixture in the boiler. The secondary air is injected into the burners via secondary and tertiary air nozzles to initiate combustion at 1300 degrees Celsius to 1700 degrees Celsius. The generated heat from the combustion process is channeled to water tubes in the boiler walls, and then the water turns into steam at 40 bars and 540 degrees Celsius. The steam produced flows into a turbine, which spins a generator to create electricity. After the recirculation, the steam is delivered in a condenser, where it is cooled and sent to the boiler to heat it again. The coal combustion byproducts, such as fly ash, boiler slag, bottom ash, and flue gas, are being captured. Common particulate control devices such as electrostatic precipitators, bakehouses, wet scrubber, and cyclones remove coal combustion byproducts from flue gas. The two most common control devices are ESP and bakehouse. The efficiency of bakehouse easily reaches up to 99%, whereas electrostatic precipitator is able to hit 96% of removal efficiency. With that, cleaner flue gas will be released into the atmosphere.
Hello, I'm Elaine. We have done a literature survey related to the particular emission of coal-fired power plants. We want to situate our project in relation to the existing knowledge. Several papers were extensively reviewed and 5 papers were summarized in the table. The study sites were India, China and Indonesia were those countries heavily count on coal-generated power stations. Anthracite, bituminous, and sub-bituminous coal were used in those plants. The material loading or the coal loading varied from 162,000 kilo per hour in Java to approximately 500,000 kilo per hour in New Delhi. The emission factors fluctuated in between 33 to 50 gram of particulate per kilogram of coal. Emission factor is a basic tool in developing national, regional, state, and local emission inventories for air quality management and in developing emission control strategies as set by the United States Environmental Protection Agency (EPA). It is a representative value that attempts to relate the quantity of a pollutant released with the activity associated. According to the research teams of Tong and Xu, emission factor is the multiplication of ash content in coal, ash retention factor, and mass fraction of particulate matter. Meanwhile, Zhao and the others reported that emission factor is the product of ash content in coal, ratio of bottom ash to total ash, particulate mass fraction, and removal efficiency of pollutant control technology. The calculated emission factor will be substituted in the fundamental equation of particulate emission. As stated by Segner, the rate of emission is the product of emission factor and amount of material loading. Implementing equation 1, the emission factor is calculated to be 20.1825 gram per kilogram. At the same time, the rate of emission is 3,269,000 kilo per hour when we work out using equation 3. All the values are extracted from numerous research papers due to the incompleteness of data. Now we will figure out the minimum efficiency requirement of air pollution control device to meet the requirement of the Department of Environment, DOE. Particulate emission standard for coal-fired power plant is 30 mg per cubic meter regardless of new or long-existing plants. To calculate the particulate concentration, we need to divide particulate emission rate by volumetric flue gas flow rate. We obtain 10,895 milligram per cubic meter of particulate. Minimum efficiency of particulate control device is equal to particulate concentration emitted minus particulate concentration allowed by DOE over particulate concentration being emitted, and we have to time it by 100%. The minimum removal efficiency must reach up until 99.72% to satisfy the rules and regulation. As part of ongoing effort to strengthen control of coal power plant emissions, an early estimation of particulate emission is vital. To sum up, the result from this study can be used for source apportionment and emission inventory calculations. Policymakers and local authorities use emission inventories to determine significant sources of air pollutants, to target regulatory actions, and also to check the effectiveness of control device. The effect of air pollution is deadly, and we should be a part of the solution, not part of the pollution. And that's all from us. Thank you.